Unit 7, Lessons 12 and 13, Practice. Number 1. Which is larger, the number of meters across the Milky Way or the number of cells in all humans? Explain or show your reasoning. Here was some useful information they gave us. The Milky Way is about 100,000 light years across, or 10 to the 5th light years. There are about 37 trillion cells in the human body, which is 37 times 10 to the 12th power cells in one human. 1 light year is about 10 to the 16 meters in distance, and the world population is about 7 billion people, 7 times 10 to the 9th. If we multiply for the Milky Way distance, the 10 to the 5th light years times 10 to the 16th meters, that is 10 to the 21st power meters across the Milky Way. All human cells would be 37 times 10 to the 12th times 7 times 10 to the 9th. If we rearrange these, we get 37 times 7, and then we get 10 to the 12th times 10 to the 9th, which gives me 10 to the 21st. 37.7, 37 times 7 gives me 259 times 10 to the 21st cells. So therefore, there are more human cells in all humans than there are meters across the Milky Way. Since there are 10 to the 5th light years and each contains 10 to the 16th meters, that's about 10 to the 21st power meters, and each human contains 37 trillion cells, and there are 7 billion humans, so that is 259 times 10 to the 21st cells, or the human cells are about 260 times more than the number of meters across the Milky Way. Number 2, write each number in scientific notation. We did the first two together in class. One was a large number, 14,700, converted to scientific notation, 1 and 4700ths, times 10 to the 4th power. B, a small number, therefore I'm going to have a negative exponent, 8.3, or 8 3/10 times 10 to the negative 4th power, because I would have to move the decimal 4 places to get it to between the 8 and the 3 to make it proper scientific notation. On C, we have another large number, so I'm going to have a positive exponent, 7 6/10 times 10 to the 8th power. Here we have a small number, so I will have a negative exponent. I have to move my decimal 2 places to the right, which gives me 3 8/10 times 10 to the negative 2 power. Notice the next number is also a small number. I also have to have a negative exponent, but I only have to move the decimal 1 place to get 3 8/10 times 10 to the negative 1st power. On this number, I don't have to move my decimal to get a number between 1 and 10. So, since I don't have to move my decimal, this would be 3 8/10 times 10 to the power of 0. Another word for 10 to the power of 0 is 1. So 3.8 times 1 still gives me 3.8. Question G. You have this large number, and to get the decimal between the 3 and the 8, we have to move the decimal 12 places to the left, and that's a very large number, so it's a positive exponent of 12. 3 8/10 times 10 to the 12th. Here, a very small number. I need the decimal behind the 9, so I have to move the decimal 10 places to the right, which is a negative 10, so 9 times 10 to the negative 10th power.